How's it going, everyone? Welcome, Ole Gonzalez again. So, in this video and in this series of videos, we're gonna see how Node.js work behind the scenes, and this is a course taught by Will Sentence as a way for us to know down deep the inner mechanism of Node.js and actually truly understand this and be able to describe that to your clients or business partner, colleagues. And the point of this is to not only describe that, right, but be effective and efficient when it comes to provide some sort of solution using Node. Now, this is a course that, let me actually put it here. So way to say, hey, the start date of this course is February 17 and 2005, right? There's some phrase to remember, right? Repetitio e master studiorum. But again, the idea of repetition is not for the sake of doing. It's for the sake of understanding. Now, let's get into this. And here, let's going to see first is the preview. Let's going to now boil down is that into our docs.
Hello there, and welcome to Node Hardparts. I'm Will Sentence, and I'm Codesmith Coding School based in Los Angeles, New York Online, and today we're going to look into Node. In this course, we're going to cover many of the most important features of this incredibly popular and influential technology. This technology is used by companies as wide-ranging as Netflix, Uber, LinkedIn, IBM. We're going to discover how do servers work.
This is exactly. Again, just to recap this from the scratch. So this is so we are going to see how servers works. It's important.
It's the nature of HTTP, the request and response object.
Okay, the nature of HTTP. The nature of the HTTP. The request and response object. Okay.
We're going to go deep on exactly what happens when we run JavaScript code to control our computer's internal features.
We are going to see how JavaScript works to control our OS feature, right?
Code to control our computer's internal features.
Okay. To control our computer internal features. I think this is something important to understand, and if we take a look at the code, it'll be much better, at least to know and be able to describe that, and therefore also build applications on top of that. So here we're gonna see this, right? C is how servers work, right? Then the nature of HTTP request and response. Okay. And why so slow? How JavaScript control our computer internal features. Okay.
This is going to be the crux of what Node does. Then we're going to
the crux. Define crux, bro.
features. This is going to be the crux.
This is gonna be the crux. This gonna be the crux. Urban Dictionary. You know, it's like, what in the F is this? a version of saying that you are mad at someone. To be under the influence of alcohol. Nail me to cross. Put me. I don't think this is Urban Dictionary. Slang for injecting heroin. No. The meaning of cross is a structure consistent of an upright with a transverse beam. So this will be the cross of what Nodes does. Okay. This will be the cross of what Node does. Why are you so slow, bro? Anyway.
Of what Node does. Then we're going to dive deeper. We're going to explore streams. We're going to explore asynchronicity.
Okay. Explore. Amen. Explore streams. Explore stream. Asynchronicity, something that I'm quite familiar with. So
Callback queues.
the event loop, the callback queue, and the microtask queue,
and the call stack itself.
and the call stack.
All of this tied together is going to give you the ability to tackle any new feature that emerges in Node and build out performant and effective servers in your teams and in your development projects.
With the goal of knowing how to build servers, which is we're gonna squeeze the power of projects. So with the goal of how to build servers, how to build effective servers, to squeeze the last drop of computational power, because it's that to squeeze the last drop of computational power in your projects.
So I'm thrilled to have you along for this course. I look forward to seeing you on the inside. We have in 3 lines of JavaScript.
All right, so let's get into this. And because of course this is a course that you are not going to see me taking notes. You're gonna see me only taking notes out of this course. I already received a red flags from this, so you're not gonna see that course. So yep, let's get into this. All right.
Welcome to Node, the hard parts on servers, and the most powerful technology to emerge in the last 10 years in the web, Node.js. My background, there it is. I run CodeSmith, a coding school based in Los Angeles, and New York, and online. Created IceCon, a library for WebRTC back in the day. Worked with some gem, yes. My wonderful family, sisters, that's the CodeSmith team from a while back. That's our old LA office, super up to date. So, Node.js, as I say, is the most powerful technology to emerge in the last 10 years. It's going to allow us to build applications that enable us to handle millions of users at once. Some of the largest companies in the world, therefore, use it. LinkedIn, Uber, Netflix, IBM, all of them use Node. But not only that, Node is going to allow us to build out applications in a desktop apps, compatible with Windows, Mac, Windows operating systems, Slack, Twitch, VS Code, Atom, all use code as part of this packaged up electron. But that's not enough. We can also use Node to set up hardware with embedded systems that use Node as well. This technology is at the forefront of doing the web. Perhaps best of all for us masters, we can outline applications end to end from what's known, see more about this,
The client and the server. Mm-hmm.
One language, JavaScript.
So yeah, so this is quite interesting in terms of, because I'm quite familiar because I am familiar with the web, but not with the, for example, okay, why not? For example, yeah, this is made of the introduction here. So introduction, enough man. Core sections introduction, using Node APIs. Node with HTTP. Node with HTTP. All right. Event error handling. File system streams, something that I am not that quite familiar with. So file system streams, Jesus, asynchronicity in Node. This is something that I am quite familiar. Asynchronicity in Node. Yeah, I know. Asynchronicity in Node. Right? Pretty straightforward. Nothing too fancy. But the point of this is to understand now and have a mental model of how the things actually work behind the scenes, especially for streams, because I don't know how to handle that. I don't know how to word that, and this is one of the powerful stuff of Node.
What it actually is to open a web application. What does that even mean? What does that even look like? Well, let's get started. Let's suppose we have in our audience, three of our audience members. Let's suppose we have Michael, and Michael is going to open his Mac. Open his Mac. It's going to load up twitter.com/Michael. Get Michael's tweets. Open it in the web browser. There's our little Chrome web browser. Okay, then we're going to have, we'll have Rich. Excellent. Rich in our audience as well. We'll have Rich. We're opening up Rich's Linux.
Rich Linux.
Opens up Linux. And he also loads up Twitter, but he wants to go to the tweets about Node. About Node.js. There it is. And then we'll have Zep. And let's see, Zep opens his phone, and Zep's phone opens up, there it is, and he also opens up the web browser, and he opens up twitter.com. Here's just the homepage. These are web applications. They need code to run. That's the three languages we're going to have run at this point to open Twitter, and they need data to load up when that code runs. Zep, what's the three, that's right, three languages for load web apps? What's the three languages we need, Zep? HTML, CSS, and JavaScript. Well done to Zep. HTML, that's going to put stuff on the page. It's going to sort of insert images or text on the page. CSS, that's going to do things on page, elements on page. Then our CSS is going to decorate and prettify them.
Decorate and prettify them.
Which is a pretty sophisticated heavy lifting language that's going to have all the
Just a sophisticated, pretty scripted language to provide interactivity to our
send messages to get further data. That's the JavaScript code in action. But we also need some data. What sort of data, Mike, are we going to load up on this Mac?
Data from the server.
Specifically for Twitter, we're probably going to have some tweets. Yeah, we're going to have some tweets. We're going to have some images, maybe some videos. This is our data. This here is our code that we need to load up. But hold on. Where's all this data and code coming from? So we're going to start with the absolute fundamentals here. We're diving into the absolute fundamentals, but from this we're going to build up to a grand vision of building out node applications. We start with absolute fundamentals. Where does this node of data come from, Zep?
From the server.
A server.
Another computer.
From another computer.
A server which is nothing but from
Exactly, for another computer.
a server.
But this information, exactly. No, and it's built up that knowledge on top of that. It's like,
Another computer.
We have node applications. We start with absolute fundamentals. Where does this code and data come from, Zep?
A server.
A server.
So here is just describing is what is a web application is, right? And this is also part of the so node overview. This is a node overview. Wow, okay. So node overview here. What is that? So what is a web application, right? To put it simple. So what is a web application? Well, so let's imagine. So let's imagine that in this case, Michael, Rick, and Seth. So Michael, Rick, and Seth wants to access to Twitter, now known as Twitter, so known as X.com, right? Since each one of them is accessing, since each one of them is accessing through a phone, through Mac, Linux, and their phone respectively, the code that loads that application is HTML, CSS. So HTML to provide structure, CSS to prettify stuff, Okay. To purify and to purify stuff. We're gonna see that later. In JavaScript, a powerful scripting language. And this is something important. Este guión o este lenguaje de guión in Spanish is a scripting language. Okay. That brings interactivity to our app, plus data that comes from something. The data that comes from another computer. Exactly. AKA a server. And all the thing that we're doing here is just to create that narrative of Node.js overview. Okay, so here we now put this. Is this one? All right, you get this. You can shrink this a little bit. Okay. So we are quite familiar with this, right? There's nothing wild about that.
Another computer.
A server which is nothing but another computer.
Mm-hmm.
Here it is, another computer connected to the internet, always on, always connected, and ready to receive a message sent out by Michael's Mac, sent out by Richard's Linux, sent out by Zep's phone. Message each time saying, hey, Twitter's computer, this is Twitter's at their headquarters, Twitter's HQ, a little message saying, hey Twitter, I need Michael's tweets, and each one says JavaScript to load them up. I need the Node.js tweets as Rich needs, and Zep needs the whole page with the tweets on it. Sends a message to Twitter's headquarters where there is a computer connected to the internet. Nothing more than that. But one is able to receive messages saying, hey, I need those specifically Richard's tweets, not Michael's tweets, and look at that message and decide, what do I want to send back? Do I want to send back Node.js tweets? Do I want to send back Michael's tweets? Do I want to send back HTML, CSS drafts? What do I want to send back? We need to determine that on this computer. What do I do, Michael, in order to, in the most intuitive, most grounded sense, what do I do to on that computer to tell it, as a developer, to look at the message and send something back? What do I write?
An application.
Oh, code.
An application code.
Exactly, I write code.
So, because this data comes from a server, another computer. Okay. Yeah, because this data comes from a server, another computer. From the Michaels, from the Michael, Rich and Seth devices, they need to send a message to that computer that is always available and to coordinate Exactly. And to coordinate all of this incoming messages, because it's about coordination, and in order to coordinate all of this incoming message and serve their content properly, we need to write code on the server. But it is about for coordinating all of this.
Alright, code on this computer introspect. That means to this message and see what it says it's asking for and decide what's sent back.
To introspect this.
Focus problem. Where's this message arriving on the computer? It arrives. But effectively on the network part. It arrives on my network. This is going to be interesting. What language? But effectively on the network. Focus problem. That means into this message and see what it says it's asking for and decide what's sent back.
And there you got it. So that computer server, I don't know why you're so slow, bro. All right. So that computer server needs to introspect those messages to get, they need to introspect those messages.
Focus from into this message and see what it says it's asking for and decide what's sent back. Where's this message from?
Why? I don't tell you to do that. Chill. Need to introspect those messages. Look into it, and decide what's coming back. Okay? All right. This message arrives. Oh my God! Why you so chill? I don't know what you're doing. This message arrives from the network car.
What languages might I want to write to control that? Well, first, what languages can I write to command swing instructions to this computer? Rich, what languages can I write?
C++.
In general. PHP, sure.
Okay. Java.
Shout out small.
Ruby.
C, C++. What we dream of, we know JavaScript really well for the clients, JavaScript. And actually, by the way, let me just hit there. If this computer's running as a server, it's going to receive messages and serve back, and the server in the restaurant serve up data and code to send back to these folks here. These are known as our clients.
So this message arrived from a network card. And the languages that we can write our code in the server machine are, well, PHP, Java, Ruby, C++, or C, and JavaScript right now. So define there. And again, it might be quite silly to do this. Some folks can think about, hey, yeah, this is silly to do this. We already know that. But what I want to do in this series of videos is to start with the basics. Okay. Start with the basics. Yep. So it's a start with the basics. So then we can then we can stack our knowledge and context with all of this deep dive. I don't know what you're doing, but enough, my friend. Enough. Enough. Enough.
Clients.
Okay.
You're asking the advertising agency, the advertising agency clients, you're asking, hey, do you have the latest assets, the latest videos, the latest images you've worked on? You're demanding, well, that's what we're doing here, we're demanding on the server to serve them back. Okay, our dream would be that we could use our computer's internal networking ability, its ability to receive a message, because that message is arriving on the network, that we could somehow use the computer's internal networking ability to look at the inbound message, introspect it, and decide what to send back. Actually, so there's a whole bunch of internal features of our computer we want to use. Let's just remind ourselves a second there. Servers are the behind the scenes of all web applications. They're where we store permanently our code and data. They're always on and ready to receive messages over the internet from users requesting, asking for that code and data. How does the computer know what to send back? We write, Michael?
Code, exactly.
What language do we use to write instructions? Well, that's an interesting question. That's an interesting question. There's a whole bunch of internal features we need to use on our computer. If we're going to send back HTML, JavaScript, and CSS, those are typically going to be stored as files on these computers, maybe hard drive.
Exactly. If we are going to send data, HTML, CSS, or JavaScript files, they are typically, well, files. They are typically files, right?
So I guess I also will need to write code to get those files, the HTML file. These are the files that get sent to code, pre-written code we're going to send back to Michael to load up his tweets. We're going to have to, I guess, access file storage as well. There's actually a whole bunch of internal features we might want to access. Here's our dream, that we would be able to use the JavaScript programming language to control these internal features. Not only because we know it, we love it, but we are experts in it. We watch Hard Parts Part 1, Hard Parts and New Hard Parts OOP, we watched them, right? We know it, we love it. But we are experts in it. We watched Hard Parts Part 1, Hard Parts, the new Hard Parts OOP. You watched them, right? It also has some really wonderful design decisions.
Mm-hmm.
They're going to actually make, in theory, using these features, a really clean experience. Right? There's a bit of an issue here. I know for sure that I cannot use JavaScript to access any of these internal features of my computer. But that's the critical thing to be able to do.
Exactly. Typically files, right? Pero qué necedad, señora. ¿Qué pasa, hijo? Ay, deja la verga. Qué necio. Alright. Jesus. You are so slow. Typically files. So, because our language, JavaScript, doesn't have the ability to access to these computer features, we'll need a way or a tool that allows to talk to those features that we need. Okay, so the network socket, the file systems, CPU for cryptography and optimizing hashing password. Okay, so the network features, or the network socket, the file systems. So file system, CPU for cryptography and optimizing hashing, for cryptography and optimizing hashing password, and optimizing hashing password with bcrypt, something that we're going to see that later, and kernel input and output management. In kernel input and output management.
When the message comes in from Michael's Mac saying, hey, Twitter, I need a new tweet, can you please send it back? And who sends the message? The web browser. As soon as you open twitter.com/Michael, press enter, sends out a message asking for those tweets. Here's the problem, people. JavaScript definitely does not have the ability to use any of those internal features. Rich, what programming language does have the ability to access those internal features such that when a message comes in asking for your tweets, Michael, the little message comes in, it lands
C++.
somehow on the network feature, the network card in some sense. What language would allow us to access and look at that message? C++. Please spot that. The glorious C++. And so, if
so the language that allow us to access to those features is C and C++, right? C++.
We are to be able to use JavaScript to access those features, to look at the inbound message, to decide what files, HTML, CSS, Java, what data, what images to send back, and to get access to them for the file storage. We're going to somehow need to make use of C++. JavaScript is going to have to work in hand with C++ so that we can write JavaScript code to control C++, build features that allow us to control our confusing terms.
Which is exactly what happened here. So we need So we need to write JavaScript to communicate with C and C++ that allow us to manipulate those features in our computer.
And these two together are known as Node.js. Why is it called Node.js? I don't know. When it's got so much C++ in it. But, there we go, people. So, C++ has many features that directly interact with the operating system, including the operating system portion itself directly. Java doesn't. So it has to work with C++ to control those computer features. It's known together collectively as.
So the combination of all of this control, think of this as a panel control, all right? So a panel control, okay, are known as Node.
JavaScript affects Node, affects computer feature. Now.
So JavaScript affects Node, affects computer features.
We're going to spend the whole rest of today, all day to come, the whole rest of this course, we're going to spend on writing JavaScript code to control indirectly via C++ the computer features we need to have access to get our inbound message and to send back a response, to send back the right data, the right tweets, the right HTML file. Does that mean I need to know C++ inside out? You might think it would. It turns out we're going to get from JavaScript a ton of labels built into JavaScript that are going to give us labels like HTTP, like FS, that we will have to sort of tell JavaScript we want to use. We'll see how to do that later on. That will give us access to C++ features that give us access to the confusing terms. Now they might feel like, well, we need to know about those C++ features. We don't need to understand and write the code. We need to know them. We definitely need to know them. They are going to handle them to the confusing terms. Now they might feel like, well, we need to know about those C++ features. We don't need to understand and write the code. We need to know them. We definitely need to know them. They are going to handle a vast amount of interaction with this underlying operating system features, like the file system, like the network. So we better understand this portion intimately. We do not need to know C++ code to do so. We do need to understand the mental models and how it's working.
So, so since JavaScript, since in JavaScript are labels that are exposed to us from the node, or from the control panel, from the control panel, Node.js, that is written in C++, okay, that is written in C and C++. Okay, absolutely. We don't and here is the key part. We don't need to know. We don't need to know that language. But what we need to know is the mental models around that.
And how these JavaScript labels are going to trigger C++ features. And that's what we're going to spend as of today. It gives you an understanding of how JavaScript labels take command
What you
from
doing
C++
there?
and get a ton of help from Node builds understanding of how JavaScript labels take command
around that. How JavaScript labels takes commands
through C++ and get a ton of help from Node.
How JavaScript labels take commands to C++, because it's that.
And gives you an understanding of how JavaScript labels take command through C++.
Okay, how JavaScript labels take commands through C++. Okay.
And get a ton of help from Node built C++. Much of Node is the C++ code in order to take command of the internal features of our computer.
So how JavaScript labels take command through C++ and command and control our computer's internal features. And that'll be all for this video. Take care. Bye bye.